Okay, so the name is cubic, and the parent equation, students, is y equals x to the third. Now, y equals x to the third. Dylan, what's the exponent of the parent function? 3, good. So exponent. Now, sometime you will also hear me say the degree, okay? So the exponent or the degree, the biggest exponent of the equation. So you only look at the biggest exponent of the equation. In this case, we only have one term, and that's x to the third. So the degree or the exponent is 3. Okay. Now the HK form, it's very, very similar to all of the ones we've already studied. Where's the value of A located? Is it always where? In front. Where's the H? Always. In the parentheses. Where's the K? Always, if we have any. At the end. Very end, if we have any. Okay. So again, the only difference is the degree. The degree of a cubic is always what, guys? 3. Okay, so that's the difference. Okay. Now this one says graph the parent function. We are going to pick these x values. Have we seen these x values before? Yeah. For sure. All of the other ones we've used the same x values, okay? So we're going to go -2 to the third. So Devin, what is -2 to the third? -8. Yep, it's -8. Okay. Grace was 1 to the third. I'm sorry, -1 to the third.
-1.
Yes. Guys, it's an odd power. Anytime that we have a negative number raised to an odd power, it's definitely a negative still. So Tanner was 0 to the third. Good. Holden, 1 to the third.
1.
Good. Zoe, 2 to the third. Good. We're going to go plot. So -2, go down to -8. -1 is -1. 0 is 0. 1 is 1. Now, is this a V, students? Is this going to give us a V? No. Is it going to give us a U? No. Is it going to make a straight line? No. So, make sure you guys make it nice and smooth. What shape should we give this? A curve? Almost like a lazy curve, right? So a cubic function, students, the parent function is going to look just like this every time. Now the transform one is slightly different because it moves right, moves left, it gets fatter, gets skinnier, but the shape of it should still be the same. Now, for this one, we do have a point in the middle. The H and the K in the middle is like that. But it's no longer called a vertex, student. A vertex is either the high point or the low point, but for a cubic function, it's called an inflection point. Okay, so it's always the point in the middle. And what is the inflection point for the parent? 0, 0. Yep, because we don't have any transformation, no H, no K. Now, what is the axis of symmetry based on all of the ones that we already studied? Axis of symmetry is a line. What happened to that line?
X equals 0.
Yeah, when you fold it, right, the left and the right should be exactly the same. Do we have an axis of symmetry where we fold it left and right would be exactly the same? Not really. Would you guys agree? But technically, could I fold it twice and then it would be the same? Yeah? Okay. So what if I fold the first time? I'm going to use my dash line. Don't do anything. Just kind of pay attention. Would you agree that's folding number 1? Can you see that right there? Is that okay? So if we fold it right there, what happens? Is that now the same? How about we fold it again? Flip top to the bottom, bottom to top? Okay, so later we will study that if we fold it twice, meaning that reflect over x and y, then it'll be the same. Now it's gonna call the origin. Okay, but we're gonna save that for later. So right now, this one does not have any axes of symmetry. Okay, but right now we're gonna say it doesn't have any, just for right now. All right, now all of the characteristics, we will study that on 2.7 by Mrs. Lloyd. All right, let's review transformation. This will help us out on the quiz as well. When A is negative, what do we say? Reflect over x-axis. Okay. All right, Jacob S, when the absolute value of A is less than 1, like a half or a quarter or 3/4, Jacob S, what is the transformation?
Vertical compression.
Yeah, exactly. Vertical, are you guys okay with me writing V dot C? Vertical compression by factor of A. On the quiz, you can also write V dot C. Now, when A is bigger, okay, than 1, like 3, 4, 5, 6, 7, 8, 9, 10. Ian, what's the transformation? Vertical stretch factor of A, whatever that is, okay? So if it's 100, then we are going to multiply by the y by 100, and it's going to get a lot bigger. Now, H, when we have a positive H, Hannah, what direction do we go? Right, good. And when we have a negative H, Farrah's not here, a negative H, Anna Sophia? Left, good. Perfect. Now, when we have a positive K, Sibby's not here. Positive K, Tyler is not here. Wow, where are my people? Annalise, when we have a positive K, hun, where do we go?
To the right.
Well, right is H. K is, huh?
To the left.
Nope, negative H would be left.
Up.
Up, positive K goes up. Parker, what happened when our K value is negative?
Down.
Good. Perfect. Okay. All right. So we have some guidelines here to help us out. I'm going to put it up here and then I'm going to read it out. I'm going to give you guys a couple minutes to start and then we'll read it out together. So Cameron, can you help us read number 1 of the steps to graph of cubic functions?
Identify the parent function.
Correct. So figure out what the parent function is. Very good. Emma, can you help us with number 2?
Make a table of values for the parent function.
Exactly. Make a table of parent. It's easier to use that. Okay. Brad, can you help us with number 3?
Identify A, H, and K.
Correct. Those are going to be on every single function. Keely, can you help us with number 4?
List the transformations from the parent function.
Perfect. Chris, can you help us with the next one, please?
Make a new table of values in the transformation.
Yeah. So guys, the H is going to be added or subtracted to your parent function x. The a value, we multiply to the y, and the k could be added or subtracted to the y as well. Sophia, can you help us read number 6? Exactly, good job. And Lauren, can you help us read 7? Yeah, we'll save that for the next section. Okay. We'll leave this here for you guys to copy. Again, if we are ever going too fast, please just let me know. We'll slow down. So if your equation has a degree of 3, what shape does it make? What shape does it make if your equation has a degree of 3? What do you call it?
The curved line.
Yeah, the lazy curve, right? Almost like an S. Would you guys agree? In a lazy format. Sometimes I call it lazy S because this doesn't really curve down all the way with the. That looks like an S. Okay. Is it a V for the degree of 3? No. Is it a U? No. Is it a straight line? No. So it's like a lazy S. Okay. Hey, Kyle, am I going too fast, hon? Not really. Okay, cool. Let's go. Kyle, can you read the instruction to our last 2 examples?
Identify A, H, and K, and list the transformations, the graph, and find all the defining characteristics.
Okay, yeah, so the characteristic, we'll save it for the next section. Example 2 says, y equals 1/2 times x minus 4 to the 3rd power plus 3. So this is the degree of the equation. So student, what is the degree of this equation? 3. So we know it's this shape, right students? Okay. All right, A, H, and K. Lonnie, what is the A value for example 2?
1/2.
Good. Jasmine, what's the H value for example 2? 4. Juliana, what's the K value for example 2?
3.
Perfect. Let's take the transformation straight up. We have 3 of them. All right, Ethan, A equals 1/2. What is that transformation? When A is 1/2, how do we state the transformation? Talk to your team. Factor of how much? 1/2. Thank you. All right, Sam, H is 4. Tell me the transformation.
4 units to the right.
Good. 4 units to the right. Can I write right 4? Is that okay still? Yeah, that's okay too. Haley, K is 3.
Yes.
Right. Tell me the transformation.
Oh. Up 3.
Yes. Good job, hon. All right. We will start with the parents over here. Parents, y equals x to the what power? Katie's not here. Where's Katie? I have so many absents. Okay. Margot, no, wrong class. That's first period. Woo. All right. Val, what's the parent equation? Y equals to what power?
3.
Good. Okay. So guys, we have 5 x's that we're going to use. -2, -1, 0, 1, and 2. Can you quickly fill in the 5 y values for the parent, please? All right, Parker, get ready to give me the 5 y values, okay?
Okay.
All right, what are they?
The first one's -8. The next one is -1, 0, 1, 8.
Perfect. Then we're just going to use our a value, multiply that to the y. H value will be added to the x since it's positive. K will add it to the y since it's positive. Okay. Now we're going to take each x and transform. Anna Sophia, -2 plus 4 is?
2. 2.
Good. Okay. Hannah, negative 1, plus 4 is? Good. Jacob S, 0 plus 4 is?
4.
Good. Zoe, 1 plus 4 is? Good. Holden, 2 plus 4 is?
6.
Perfect. All right, here we go, Tanner. Tanner, negative 8 times a half is what? Good. And negative 4 plus 3, Tanner, is? Perfect. Grace, negative 1 times a half.
That's negative 1/2.
Good. And then we're going to add 3. So what are we going to get?
That would be negative 3/2.
Remember, think about this. Is that the same thing, Grace, as taking 3 minus a half?
Yeah.
Yeah, so what's $3? Take away 50 cents.
$2.50.
Right, 2.5. Good job. All right, so Devin, 0 times half. Good, plus 3. Good. Dylan, 1 times a half. Half, plus 3, Dylan? Yes. All right, get ready for this one, Jacob G. 8 times a half, Jacob. 4 plus 3? Perfect. All right, guys, plot those. Ready? 2 is going to be negative 1. Oh, that's not 2. Duh. 2 is negative 1. 3. I'm going to go up 2.5. So check and check. 4 up 3. 5 is now 3.5. 6 all the way to 7. Should we connect those 5 dots and make a straight line? No, make a lazy curve, okay? Make a lazy S here. Make sure you guys make it nice and smooth. Look at that. Where would our inflection point be, students? Remember, it's always h comma k. So what is your h comma k here? Hold on. 4 comma 3. Good. That is the point right in the middle of the curve. Does that make sense so far? Not a line, it's just a point right in the middle of the curve, okay? All right, I'm gonna hold it right there so you guys can take the notes down. If you can start on example 3, that would be great. List the A, H, and K. Don't forget arrows on both ends of our graph, okay? On example 3, go through and list A, H, and K. Haley, am I going too fast, hon?
A little bit.
Okay. Are you okay still? Are you done with example 2 or are you still copying?
I'm done.
Okay, so I'm gonna slow it down for you. All right, let's go do this one. All right, Sam, what degree is our example 3? Yeah, third degree. Degree is going to be 3. Anytime you have a degree of 3, it's going to be a curve of some lazy looking curve, just like that. And then it's going to change a little bit depending on the reflection, okay? So, Ethan, A is what for our example 3? Good. H is what, Juliana? Perfect. Jasmine, K is what? I think you meant to say negative. K. K is? Negative 3. Good. Let's do the transformations, okay? Lonnie, negative 1 for A. What is the transformation? Good. All right. Kyle, whenever you're ready. When H is negative 2, what is the transformation? No, when H is negative 2, how do we state the transformation? Not right. It's just negative. So what direction is that? Left. Thank you. When K, Lauren, is negative 3, Lauren, how do we state the transformation? Good. Okay, so let's do the parent first, students. We're going to be x, and then over here, we're going to have y equals x to the third. Sophia, give me all 5 x inputs for the parent.
0, -1, 0, 1, 0.
Great. Chris, give me all 5 outputs for the parent.
For the y,
Yeah.
so it'd be 8 or -8, -1, 0, 1, or 8.
Good. So we have an h value of a -2. So now take the parent and subtract 2. We have an a value of a -1. So we're going to take the -1 times the y parent, and then we're going to minus 3. Okay. All right. So guys, take all your x's for me. Take all these x right there and transform. Subtract 2, and then let me know what you get. Okay. At the same time, take all the y's here and then multiply by -1 and minus 3. So you should have 5 new inputs for our equation and 5 new outputs. Keely, whenever you have the new x values, can you give it to me?
Yes.
Okay.
-4, -3, -2, -1, and 0.
Perfect. Some of you are all done. Cool. They will be inflection point for me. If you're done, that is. All right, Brad, do you have all the 5 new y values, Brad?
Yes. 5, -2, -3, -4, -1.
Someone agree, disagree? I want to make sure that's all correct before I plot those. Was it good? Okay, thank you. All right, let's plot. -4 is going to go +5. -3 is -2. -2 is -3. -1 is -4. And 0 is going to be -11. That's a bit off the grid, and that's okay. Make it nice and smooth. All right, inflection point. Okay, this is inflection point right there. Remember, inflection point is always h comma k. In this case, Emma, what would that be?
-2, -3.
Perfect. And I believe we are done with 2.6.